A very warm welcome to today's expert webinar on data science with Python, a hands-on approach. I am Ankita from SpringPeople. We are India's largest enterprise training provider. I'll be your moderator for today's session. We are thrilled to have you with us for this exciting session. In this session, we will be diving into the world of data science using Python with a focus on practical applications that you can actually use in real-life projects. We are honored to welcome our speaker for the day, Ms. Amudha Adhirai, a seasoned corporate trainer with over 9 years of experience in a wide range of technical domains, including Python, C, C++, Java, AI, machine learning, data science, Power BI, and many more. She's worked with top clients like GE Health, TCS, Volkswagen IT Services, and Comcast, delivering impactful sessions that break down even the most complex topics into something practical and easy to grasp. With her incredible industry experience and engaging teaching style, I'm sure you're going to find this session extremely valuable. Now, participants, if you have any questions, please do share them in the question box. They will be answered at the end of the session. Without further ado, let's start today's session. Over to you, Ms. Amudha.
Thank you so much, Ankita, for the brief introduction. Going further, let me introduce myself. I am Amudha, so I am the technology evangelist, and here we are going to discuss about the data science using Python. And my area of interest is data science using Python. Okay, so let's go on. Now we are going to discuss about what is data science. So it is the field that uses the data to understand the patterns, making the decisions, making the predictions, and also help in decision making. So it is the combination of the statistics and the mathematics. So there is programming involved, there is a domain knowledge and the data visualizations. So roughly I can say the data science is roughly, I can say that data science is to turn the raw data into some useful or meaningful insights. So now, why we are using this Python? Let me move on to the next slide. Okay, so why we are using this Python for this data science? So it is one of the popular language for the data science because it is very simple, easy to read and write, and also there is a huge collections of libraries. Say for example, there is a NumPy, Pandas, Matplotlib, even the Scikit-learn, and we are going to discuss very detailedly further. So it also has some strong support from the data science community too, and it is going to works well for the automations even. So data cleaning is very important and the analysis and the overall machine learning process. So like here, what can you do with this data science while using this Python? So using this Python, you can analyze the trends and the patterns in the large data sets. So say for example, making predictions. So making predictions in the sense you can do with example like sales forecasting, diseases detections you can do, and here you can visualize the data and the graphs and the charts that we are going to do it, and you're going to build some machine learning models also. I'm going to express some example or how to build a machine learning model, some example I'm going to show you, and how to automate the reports, and you're going to see the dashboards of it, everything that we are going to discuss. So the popular Python libraries is accordingly it is NumPy, Pandas, Matplotlib, Seaborn, Scikit-learn. So there is some real world examples also here we are going to discuss with the various fields, right? There is some real world example. Like in healthcare, we can use this data science, and in retail, we are using this data science. In the finance field, we are using this data science in the social media. Say for example, the healthcare means like you can use it as like, say for example, predict the patient diseases from the symptoms, and it is for the retail. So here you can analyze some customer buying behavior. So in the case of finance, like you can detect the fraud in the transactions, and in the social media you can use the data science as like sentiment analysis from the tweet. So these are some basic things that you can have in the data science things. So it is various fields we are using like finance, healthcare, marketing, and more. Okay, and let's discuss about the data science cycle, which is data science life cycle. So this is a step by step process that the data scientist follow to exact or extract the insights and build the predictive models from the data. Say for example, from the beginning of the data, from the beginning means like we can start from the business or the business problem understanding. So what is this business problem understandings? In the sense like understand the business problem or understand the question. Okay, say for example, can we predict customer churn next month? So this is what the problem, this is what how you understanding the problem. So after understanding the problem, so then we are going to do the data collections. So now after understanding the problem, you need to gather the right data from the various sources. So sources, it can be anything. It can be databases, it can be CSV files, it can be APIs, it can be web scraping, even sensors also you can collect. Say for example, so collect customer transactions and support history is the data collections. So after that, we are moving to the pre-processing work, which is nothing but a data cleaning. So here you're going to prepare and clean the raw data. So the task here they are doing as like removing or filling the missing values you're doing here, even handling the data, mean duplicate data here, like correct the inconsistent data, only it is going to provide the relevant information. Example, so it is fix missing the age values, and also it is removing the duplicate rows also. All these things will be done in the data cleaning or the pre-processing phase. So the next phase is now we are in the exploratory data analysis, which is EDA. So here the data exploration is going to be done. Say for example, or I can say understanding the patterns, understanding the trends, and understanding the relationship between the data. So the graphs, the charts, the summary statistics are using this exploratory data analysis. Example, we are going to visualize the age distribution here or checking the correlations using the heat map. So these are the EDA process. And now next it is move on to the feature engineering. So here select and create only the useful variables, the features, the actual features or the very useful features for modeling. Or I can say features is nothing but the columns. Okay, say for example, I can say you're going to convert the sign up date to account age. So in days, you can also do that conversion. So all these conversions and the extractions is going to happen in this feature engineering. Moving further, we are going to deal with this machine learning and the model evaluation, both are same as, and I can say it is a model building. So you are going to train the machine learning models to solve the problems. And some of the common models we can discuss like linear regressions, some decision trees, and you can have this random forest. So these are the model evaluations. So the tools it is mostly used to build the model, it is Scikit-learn, TensorFlow, and the PyTorch. So now the model evaluation means like it is going to check how your model is, how good your model is. So say for example, it is going to calculate the metrics, calculate the efficiency. So which means using the accuracy, using the precision, using the recall, F1 score, ROC. So these are some metrics, examples of metrics. Like say for example, we can say is the churn prediction model 90% accurate or not. So this is what the model evaluation. So finally, we are going to step into this data visualization phase. So in this data visualization, so we are going to express this in the form of deployment and when the maintenance phase also included. So put the model into the use, which is real world applications. You can build some dashboard, automated email alerts, whatever maybe, that is a deployment. And the monitoring and the maintenance is field, that is going to track the model performance over time and update when needed. So this data and the patterns change, it is called as data drift here. So this is how the full data science life cycle is exist. So now we are going to discuss about why Python for the data science. So we had data science about, we worked about data science, and now we are going to discuss why this Python is more important, why this is the first choice for the data science, especially for, it is especially useful for the beginners. Okay, so first the thing is it is easy to learn and read. So I'm going to express with some hands-on examples. Say for example, I'm using this Google notebook. or Google Colab notebook. You can use any IDEs. You can use Jupyter, you can use Spider, you can use Visual Studio Code, that is of your wish, and I'm using this Google Colab. So in this Google Colab, this is the code section and this is the text section. So I'm going to write something in the code. Okay, I'm taking some code section. So now it is very easy to learn and read, which means that I can, whatever I want to print, yes, I can print. So let me, within the semicolon, I can print data science, that I can do. So it's very easy. So just if you want to print something, yes, data science is going to be print. So here in this Google Colab, it is actually connecting. This is actually connecting with the cloud, and this is turned into a green color signal and the output is received. So the successful execution has completed, right? And this is how very easily, if you want to print something, you just print. Without the print statement also you can print. So next we can discuss about, you no need to externally specify any number. Say for example, if I'm printing something like with the function, if this is my variable, age is variable and is greater than, I'm specifying some 18, and you are going to print. Okay, so print some, you're eligible. Okay, else you're not eligible, like that you can print it. Fine, let me, okay, this error because, okay, any age is not defined, so we need to define this age before. So just you need to define this age, so you're going to get it. Okay, like I'm going to define age. Okay, and you're going to have it. So just define and you're going to have it. And now let's do it on just simple statement you're going to have. So let's do it with I can say some maybe I can use something like, you can do the arithmetic operations over here. Maybe I can calculate some exponentiation 6 asterisk asterisk 2. You can calculate and you can give 6 exponentiation 2 is 6 power 2. So I'm going to get some 36. So all the mathematical operations that you can perform here. So I can also even have some something like I can say maybe 7 is greater than 2, like I'm going to get the Boolean result. Yes, it is true. So you can have this comparison things. It is very simple. Okay, just to print the string, just to make the, like, powerful arithmetical calculations that you can do. So it is very useful. So also it has some very good rich libraries which we are going to discuss about these things, which is uh, which is about the NumPy. This NumPy is we are going to discuss, and the Pandas, we are going to load the data sets with the Pandas, the Matplotlib, all the plotting data visualization libraries, the SNS, it is advanced data visualization library we are going to discuss. So all these things makes the Python is very simple. So that is why we are using Python, and we are going to take this Python as a first choice for the data science. And so it is also very powerful for the machine learning because of the Scikit-learn. So we are having another thing is called Scikit-learn. So Scikit-learn is one of the important machine learning library. So this is Scikit-learn. So this is what Scikit-learn, it is going to hold all the classification, regression, clustering, which is very much helpful for the machine learning process. So dimensionality reduction, model selections, pre-processing work, everything is going to discuss with this Scikit-learn. Okay, so we are going to use, we can search the data set. You can have some temporary data sets also over here. So I can search some data sets here. So you can have some dummy data sets over here. So sklearn datasets is holding. See, these are the datasets you can have. Something like toy datasets if you use it. See, you're having load iris, load diabetes, load digits, all these things. So load wines, all these things are dummy datasets, so that you can have some like, a dummy like, or you can say synthetic workouts, or like to provide some prototype for this. All these things that we can do with the help of this Scikit-learn. And this supports this large community and the resources, which means that So there are tons of tutorials is available, tons of forums is available like Stack Overflow, and the GitHub projects is there. So it is a strong community support, makes it very, very easier to get help and grow. So most of the top companies like Google, Netflix, Spotify, NASA, and many startups also using this Python for their data pipelines and also for the AI projects. So it is also works well for the other tools, like you can integrate this Python with Excel, SQL databases, even big data tools like Hadoop and the Spark. Even you can use it with the web applications and the dashboards, like you can use with Flask and the Streamlit that you can do it. So all these things makes this Python is very, very suitable for the data science. It's a first choice maybe. So there is I can say, so like there is a large community support is there. So large community support in the sense like it is it's like large and active community, and that makes a huge difference, like especially when you're learning or working on the real world problems. It is very important to have tons of learning resources, right? So there are free tutorials, there are online courses from Coursera, so many things, like you're having some documentations and the official guidelines is there. There is some active question and answer forums is there. There is some open source projects, like say for example Kaggle. You can have tons of notebooks in the competitions with Python based solutions is there. Even in the GitHub you can study real code, and even the contributions you can do. There are ready-made projects and the notebooks are there. There are online communities and the groups, say for Reddit subs, like some links is there, or data science, and Discord and Slack groups for the Python and the data science learners is there. This is one of the community. Meetup groups is another group. It is one of the community for virtual and the local for networking and learning. There are so many library maintenance, and the contributors are there, like popular libraries you can use it, which is very, very actively maintained. Issues are quickly fixed and the new features are added regularly. You can even contribute them with a great for your career growth. So very importantly, job market advantage, because of this Python is so widely used. Interview questions, job descriptions, and the test cases are very well documented. So you'll find lots of interview prep materials, practice your test, and career advice from people already working in the field. So all these things are, make it large community support. Why this is matters for you? Because you are never alone. If you face any challenge, someone else already has. So learning is faster and more practical here. You can keep growing with the help of supportive global community here. And this is very efficient for handling the large data sets in data science, which means efficiently it can handle the large data sets. So like I can say, optimized libraries for the speed. So the optimized libraries, or I can say it is, there is a NumPy, I mentioned Pandas, there is a Pandas, there is a Dask, there is a Modern. So these are extremely very, very efficient for handling the largest data sets. And smart data handling techniques also we can have. So smart handling means like there is some in a process which is chunking, filtering before loading, and the lazy evaluation is there. So chunking means that you are going to load and process the data in a very, very small parts instead of all at once. So now filtering before loading means you're using tools like SQL. You can filter, or you can use PySpark to query only the needed data. And also you can do this lazy evaluation, means like libraries like Dask don't compute immediately, only when needed it is going to compute. Okay, also it is very efficient for the handling the large data sets by means of integration with the big data and the cloud. So Hadoop or the Spark via PySpark, you can Python is greatly works with. So cloud services like AWS, Google BigQuery, Azure, you can do it. Databases like PostgreSQL, MySQL, using libraries like SQL Alchemy. There is PyCop too. So these things are very good integrated with the big data and the cloud. There are parallel and distributed computing is there with the Dask, JobLib, and the Ray, or the multiprocessing. So these are the very effective, like packages for handling the large data sets. So now we are going to give a complete detail about what is NumPy, what is Pandas, what is Matplotlib, and what is about the Scikit-learn algorithm. So now let's discuss with the NumPy. So over to the NumPy, it is the most important library in Python for the data science and the numerical computing. This is for the numerical computations. So this NumPy stands for this numerical Python. It's a Python library used for working with arrays, some mathematical operations, and for the scientific computing. So think of it like as the foundation for many other Python data science libraries like Pandas, SciPy, and even the scikit-learn. So we are using this Python, so it is very very faster and more efficient, more memory efficient than using the regular Python list. So this is the over advantage of this list only. So it is going to allow some vectorized operations, like it is going to performing the operations on entire arrays at once. So you're going to provide many built-in functions. That is a very beauty of this NumPy, which is linear algebra. You can deal with statistics, random number generations, there is matrix operations, those things that we can use it in the NumPy. And let's have some basic some problems in the NumPy. Okay, so this allows the several mathematical operations and the faster operations also supports. And this is NumPy. So you need to import this NumPy as NP. NP is the alias name. So now I'm going to show you the process time taken between the list and the NumPy. So this is the time taken by the list is 0.001249 etc. And the time taken by the NumPy is 0.000040963. So from this you come to know that it is 50 times faster than the normal list. So this is how we are going to introduce this arrays. Introduce this NumPy arrays. Here we are going to pass the input as an array object. This is an array object. Okay, so now let's give the sample. So this is one dimensional array. So 1 2 3 4 is an array object, and we are going to pass this input as an array object to the NP. NP is a NumPy, and I'm storing into some variable and printing this. I'm getting this. Okay, and the shape is nothing but it is going to show you the structure. Maybe here only the rows, so it is going to indicate that it is of 4. 1 2 3 4 calculating. Now we are passing this two-dimensional array. So let's discuss with the two-dimensional array so that the shape is between 1 2 rows and 1 2 3 4 columns here. So 2 rows and 4 columns is specified. So this is how we can convert into float. You can have the initial placeholders like this 4 comma 5, and you can have this like initial placeholders with ones, with full, with I, all these things you can use. And also here you can create a random variables. So random numbers with 3 comma 4, yes, you can create 3 rows 4 columns of only the random numbers. And you can also use, instead of floating values, you can also use with normal integer values between 10 to 100. You can generate some 3 rows and the 5 columns. And there are some functions with linspace and arrange for the evenly spaced values, and you can also do the conversions. And finally coming to the point of analyzing a NumPy, so you're generating some random integers and you can find the shape, you can find the dimensions, you can find the number of elements, and checking the data type of the values. All these things you can do, and along with the operations also you can perform. So many operations you can perform, so many functions, built-in functions is there. Say for example, I can give you one important built-in function is transpose. You can convert this array into the transpose. So this 3 rows and the 2 columns is turned into 2 rows and 3 columns as a transpose. So this is how we can use a NumPy. Like you can use a NumPy for the linear algebra, for the statistics, for the random number generations, and for the matrix operations you can use. So all these things mostly used. Some like you can use create arrays, you can use mathematical operations, you can use reshape, even reshape. There is a matrix multiplications you can use. So these are some of the basic things that is used in the NumPy. So now coming to the next chapter, which is pandas. So pandas is nothing but a Python data analysis libraries. It's very, very powerful, very flexible, and very easy to use tool. So this is for data cleaning, data analysis, data manipulations, and also tabular data processing. So tabular data processing means it is going to process in the rows and the columns like Excel spreadsheets or like SQL tables. Okay, so why we are using this Pandas? So it is makes it super easy to load. You can view, you can filter and analyze the data. So you're going to handle the missing data, duplicates, and also column operations very, very easily. So built on top of the NumPy, so it's very, very fast and very, very efficient. So it's work well with files like CSV, Excel, SQL, and the JSON. So here we load the data set in the CSV format. So for that, NumPy as NP is the importing library. So another library for the pandas is import pandas as the PD. So this is the alias name. So pd.read CSV is the function where you are going to read the CSV files. So I'm just uploading the CSV file. So it is actually connecting here. I'm going to upload it. It is connecting to a runtime. It's waiting for some time. Yes, it is. Now I'm going to upload it. So maybe I'm using this data set. I'm going to use this diabetes data set. This is what I'm going to upload. So it's warning, it's asking for warning. Okay, it is generating now. So this is okay, done. I'm just copying this and I'm just pasting this path here, and this is what the diabetes CSV. Okay, and I'm printing this. This is what the diabetes CSV. So there is pregnancies, glucose. So these are the data set. Okay, and the head is used to it is used to give only the first 5 rows to check analysis, and the tail is going to give the last 5 rows. Okay, and the shape is, it is on the top of NumPy. It is built on the top of NumPy. So shape is very important to identify the number of rows and the columns. So you have here 442 rows and the 10 columns is there, and I can do with basics information. See, diabetes df dot informations I can pass. So I can pass some describe, I can pass some location, I can search some of the columns, I can take some of the rows also. Based on this first thing, it is considered as the rows, and the second one, it is considered as the columns, that we can pass it. And we can do is null. Is null is very important to check whether there is a null in the data set or not. If there is a null, it is not going to give you a proper accurate answer. And you can also check the correlation. See the correlations between each and every column it is mentioned. So you can also group by with certain limits, mean, median, mode, whatever may be. Also you can use this Excel format. I'm reading this with the Excel format, some sample data you can do. And also very importantly, you can also take the data sets from the sklearn also. So this is the machine learning library. I'm coming to this point later. And now we are going to discuss with the Matplotlib. So far we were discussing with the NumPy and the Pandas. Now we are going to discuss with the Matplotlib. So this Matplotlib is the plotting library. So where, see, I'm using import matplotlib.pyplot as PLT. So this is PLT is nothing but a alias name for this Matplotlib. And I can say this Matplotlib is like go-to tool for making the visuals and the plots in the Python. So it is used to create a static, interactive, and animated visualizations also. So like it's just like version of Excel charts or Matplot, or I'm sorry, it's a MATLAB plots. So by the way, it is more flexible and powerful also. It helps you to see the patterns, trends, and the insights in your data through these graphs. So why we are using this Matplotlib is it's a creative, and it creates a wide variety of plots also. Like you can use line charts, there is bar charts, there is histograms in the pie charts, there is a scatter plots and more. It is there, and highly customizable also. So we can have the colors, we can customize the labels, and we can mark some legends. There is some some styles over there. So it works well with NumPy and the Pandas very well, and can also export this graph to the images also. You can convert into the PNG format. You can convert this into the JPG, PDF also. So you can do this. So some example of this Matplotlib is like I'm generating this XYZ. So which is hex is holding some length space, some numbers between 0 to 10 with 100 numbers, and I'm just converting that 100 numbers into sign values and generating this cost values. I'm just printing this A, B, C or XYZ, and I'm plotting the only X comma Y where we are going to get the sinusoidal wave. This is the sine wave. So this is the simple graph, and this is a cosine wave we are developing. We're generating the cosine wave. This is the cos wave, and here is this, like you are going to adding the titles, adding the x-axis, y-axis, labels, everything like this. So you should plot like x label, y label, and this is how you need to generate a full-fledged basic graphic tool. So there is line chart, bar chart, pie chart, there is a bar chart, scatter plot, even histogram is there. I'll show you all these things. So this is how we are going to generate a parabola. See, I'm just making it a parabola with the negative markings. And you can, I told you, you can change it more colors. So it is highly customizable. So with the colors, you can change with labels. See, I'm using that R plus R is for red and the plus is for the symbol. CG is for green and dot. It should be, the point should be on dot, and R again X, red X should be there. See, I can pass some two different things with G, with green and the red color, with the single hyphen and the double hyphen we are having. So next we are going to discuss with the bar plot. This is a bar plot. So where you can have the two different like two different bars you can have, and so there you can have the labels of like languages and the number of peoples. So X and Y labels you can pass it, and the values you're going to pass, the axis you're going to pass, and this is the bar plot. So you can also change the colors, the width, the size of the bars, and you can also change each and every colors in between. So this is how. And next it is a pie chart. So pie chart is again passing some two different values with the explode options also. So you can also explode something. The Spanish is exploded from the list of languages, and I'm going to have the names and the labels as the languages here. You can have the legend also. Legend is nothing but the title, like this, like tooltip. So you can also like give this you can pass this auto picked here. So this is based on 0.1 percentage, which is this 0.1 percentage we did, and there is explode also. We pass some exploded, and there is some shadow also in this pie chart. So you can give more properties in the pie chart. And now it is, yes, this is a scatter plot we are going to use. The scatter plot is holding, see, lots of points scatterly pointed, and the various colors we are using. So initially it is only the blue color, okay, different, and there is a 3D scatter plot also where you can pass XYZ with the C is equal to Z, and the C map, the color map is going to only the blues. You can change, there are more color maps out there, so you can change with the reds, greens, even virides. You can use the options. So this is somehow the basic Matplotlib library, which is very much it creates a very wide variety of plots like line charts, bar charts, everything. So this is how this things. And this matplotlib works means like most plots are made up using this matplotlib.pyplot, which behaves similarly to the plotting in matlab. So you can also use object oriented plotting for more control, especially with the subplots if you're using subplots. And I'm going to discuss the another one important plot which is built on the top of this matplotlib for prettier and also for the statistical plots. So we are using this SNS. So in this SNS, like here, like I can say, we want to make, or want me to show, we want to make example with real data like CSV data set, means like you can explore in the Seaborn. Okay, so you can use the Seaborn. So it is very good real time data set. Along with the data set and along with the plotting library also, you can have extended this. See this. You can have the pair plot where you're going to compare the different columns, or we can say features here. And this is tips. So this is nothing but a tips, where this tips is nothing but a sample data set. Tips is a sample data set. So we are loading the data set tips and printing this. Okay, checking the head and the tail, passing the describe as okay. And I'm just checking with the pair plots here. See the pair plots. Okay, where you're going to compare a different columns here. This is a pair plot. So this is a distribution plot over here. And you can check with a rel plot, which is rel plot. You can have this rel plot with every data together. See, and we are going to use some scatter plot here. This is a scatter plot with hue, sizes, everything. And next we are going to use with the count plot. This is a count plot where you can count the number of here like females and the males based on the classes and the data who is survived or not. So based on the sex you're calculating, comparing. So all these things are count plot, and this is a bar plot. See the male and the female comparing with the survived. Okay, so all these things are the best example for generating the data. And see distribution plot. And finally we are going to use this heat map. So which is heat map is going to show you the correlation between the features. So this is how the heat map is going to execute. So these are the different data visualization tools we are using in this Python things. So next we are going to discuss with a very important scikit-learning. So I'm just going to do with the scikit-learn. This is a scikit-learn library. So where okay, this is a scikit-learn library which is very simple and efficient tool for predictive analysis definitely, and it is going to provide you, yes, of course, it is very free, open source. So I can say it is free. It is um, open source machine learning library in Python. So it is going to provide some simple and efficient tools for you're having some classification, regression, clustering. So classifications means, say for example, yes, you're having the spam detection. So whether it is spam or not. So image recognition you can use for this classification. Yes or no details. So this classification mainly for the discrete values. It is going to identify which category an object belongs to, whether this category or that category. So this is about discrete things. So this is regression all about the continued value attribute. So say for example, based on the depending features, so something is going to predict some patterns based on the dependent patterns, some new things is going to predict. Say for example, this drug response, or we can say predicting the house prices based on the like privileges, based on the facilities available in the area, we are going to predict the house prices. So next we can deal about the clustering here. So clustering is nothing but this grouping of similar objects into some sets. So where customer segmentation is the application for this the clustering. And there is a dimensionality reduction, so we can use the PZ algorithm for the dimensional reduction. So model selection is there, model evaluation is there. So based on this you can apply, like we all these things we were discussed in the data science life cycle. So all these things are uses. Why we're using the scikit-learn is it is very easy to learn and use. So it is very useful with working with NumPy and the Pandas as ready-made algorithms over here. And it is includes this data processing pre-processing tools also, and it is ideal for quick experiments and the real world applications. So we are going to discuss with some machine learning things with a classification now. Okay, so the classifications, maybe I can say I'm just downloading the data set from the sklearn. See, I'm just downloaded from sklearn.datasets, and I'm putting this low diabetes I've shown you already. So this is here, going to that, and I'm going to search this data sets over here. From the data sets, see sklearn, from the data set, see sklearn.dataset, this is the module. In this model, I'm going to download this. I'm going to take this load diabetes. This is the load diabetes dataset. This is the load diabetes. So it is holding some 442 rows and the 10 columns, which is libraries, which is features. Okay. So this is what the dataset. I just imported this dataset in this thing. Okay. So from sklearn.dataset, I just import this load diabetes and I'm just storing in some other variable. I'm checking this diabetes dataset. See, this is the data type sklearn.utils. From this only it is actually processing, and I'm printing this. See, around this dataset is very scattered. We cannot able to figure it out what is what is the column, what is the data, everything. So it's very difficult here. This pandas is going to act as a very important point. So using this data frame, so all these scattered data is going to convert into the proper rows and the columns. So I'm just including this data set dot data and the columns equal to, along with the column I need, so data diabetes dataset dot feature names is the column name. So as we discussed here, so this is the features, right? Features is there. And yes, and after this loading into the data frame, see, you are going to get a proper column name, right? Proper column name is we are getting. So this is how we are going to load the data set from the sklearn. So now let's discuss about some problems. Okay, maybe I can take this. Okay, and I can take this. Okay, so this is the example for the like linear regression. So this is implementing this linear regression from the scratch. We are implementing, see, linear regression formula. So we don't require actually all these things formula. It's uh, very easy when you're using this Python. So just importing this NumPy. This is a class for this linear regression, and you're just importing the pandas and the model selections. I'm using this training, testing, split and all I'm using. And using this, I'm just passing the data set here, and I'm doing some basic analysis, head, tail and all. Basic analysis is done. And by the way, I'm training this model and I'm checking the predicted value plus actual value here. See, the salary versus experience is done. So this is how this linear regression supports. Regression means it is going to be a continuous values. So based on the experience, the salary is going to calculate, mean the prediction. Okay. So this is how this linear regression is implemented. Now I'm going to show you the logistic regression. This implementing this logistic regression followed by the sigmoid function. This is a sigmoid function. And importing this logistic regression, this is a class file. Importing by model selections, there is a matrix. So for the regressions, we need to calculate the efficiency. We need to calculate the metrics based on the mean absolute error or mean square error or R square error. All these things are there. But in the case of this this classification, you can have this accuracy score. Going further with the accuracy score, you can use confusion matrix, precisions, recall, F1 score. All these things are the metrics under the classification. So now I'm downloading one data set. So this is the data set. So I'm finding all the shapes and everything, fixing with the X and Y. So this is a data standardizations I'm doing. So data standardization is going to formalize the data from zeros to ones. So we are fitting and transforming the data here, training the model, and the model evaluation is done. Predicting the system now. Yes, the person is affected with diabetic or not. Here the person is diabetic. According to the strategy, the person is diabetic. So this is how we are going to predict based on the classification. And there is one thing is clustering is there. So I can do the clustering based on this customer segmentation. So this is by means of k-means algorithm. So here I'm just passing this k-means algorithm. We can do some data collections and analysis over here. So all the dependencies are imported. So this is the data set. I read the data set and I do analysis the data set informations, whether it is checking null or not. So you can do the actual prediction with the annual income column and with the spending score column with the help of this particular data set X, and X I have printed with 2 values, and within this cluster sum of squares, I'm just going to calculate the formula, and I'm going to print this elbow graph. So the optimum number of 5, based on this elbow graph, we calculated that number of clusters is the 5. And now we are going to predict this based on the predictions. I just marked the number of clusters with the points. So only 5 clusters are formed. So according to this, I'm just doing the plotting. So plotting is done with all the clusters and their centroids. Okay, and now it is the plotting is this. So this is the spending score versus annual income. This is how this segmentation, which is clustering, is doing. Okay, this is the basic concept of machine learning. So with using the scikit-learn machine learning things, and now we are going to discuss about the data processing and cleaning. So data processing and cleaning in the sense like how we are going to handle this missing data, removing the duplicates, and the data transformation is making, and using this pandas we did for the data pre-processing work, all the basic analysis. So now missing data, which means that like many machine learning algorithms can't handle this missing values, which is a bias your result. So cleaning it properly leads to more accurate predictions actually. So human error in data entry is a missing data, sensor or system failure is a missing value. Those things are missing data. Some things are blank, null, and even not recorded. These are the missing data. So this is what the missing data. So you need to handle this missing data. So for this, you're going to use 2 different techniques that you need to detect this missing data by using this is null or not. We already I explained it. So I'm going to check whether this is null or not, or I can explain you with some other project also. This thing. So this SVM is a support vector machine which is going to support both the classifications and the regression. So here you are actually importing the data set, reading the data set, doing the basic analysis of the data set, and describing, and we are checking the missing values here by using this is null. So whether it is null or not. Yes, here so many null values are there, so I'm just going to handle this null values by using this drop now. So drop now is nothing but just removing the missing values. And the other thing is there is an imputation. So imputation means it is going to add those missing values with the limited mean, median, or some mode. So this is what this handling the missing values. You're going to fill with mean. When data is numerical and normally distributed, please fill with median and mode. So this is how we are going to handle this missing values. And next is removing this duplicates. So there is a thing that you can also remove the duplicates things. So yes, I'm going to show you how to remove this. Okay, how to remove this duplicate things. Like I've taken one. Fine. So we can have some code. So removing duplicates is like you can also detect the duplicated by using df duplicated. So I'm just typing the code alone. So df dot duplicated, or you can check duplicated. This is one function that you can use it. Df dot duplicates. Even I didn't mention any variable and all. So I'm just checking for this and removing the duplicate. You can drop the duplicate here, and you can keep the last occurrences instead of the first. You can drop the duplicates over there. So all these things it is meant for the removing this duplications. And the data transformation is nothing but, so it is going to convert the data from one format to the another format. The label encoding here you're going to do. Say for example, in this, okay, here I'm doing this data transformation. Say for example, everything is a categorical format: graduate, not graduate, yes, male. So everything is a like label encoding. So I'm going to detailedly discuss with this. So now I'm going to change all these things, categorical columns, into numerical values. So now everything becomes only the numerical things. See, 100, only the numbers, not the categorical values. This is how we are going to do the data transformation. Okay, you can do the standardization based on this. You can do the encoding the categorical data. So all these things are used in this data transformations. Now we are going to discuss with the flow chart. So of using this data pre-processing work, data cleaning, and the data integration, and the data detection. So all these things are the pre-processing work of Python. So all these things we were discussed about these things. Loading the data, it is by exploring the data, it is by handling the missing data, it is by removing the duplicates. You're going to transform the data, you're going to encode this categorical data, you're going to do the feature scaling over here, and you're going to split the data sets also with the using the train test splitting. So all these things are under the pre-processing work. And yes, so next we are going to do with this exploratory data analysis, so which is a process of analyzing and visualizing the data set. And we were done with the Matplotlib, we were done with the Seaborn that we were discussed already. So it is going to understand its structure, you're going to discover the patterns, and also you can find the spot anomalies and outliers also over here, and also you can give some test assumptions also. So which is EDA is more important in identifying the patterns and the correlations, everything that we were done by using practically hands-on session here. So it is going to help detect the data quality issues, giving more insights about the relationship between the variables, and it is going to inform the feature engineering decisions, also saves you from the garbage in, garbage out modeling things. Okay, so this is how we are going to use this EDA. So next, this is a sample visualization we have done. So this is based on the bar chart, histogram, scatter plot that we were discussed about it. And we were discussed about the machine learning algorithm with the Python. So supervised algorithms that we did with the regression and the classification, where we discussed about the linear regression and the logistic regressions problem. And unsupervised learning algorithm also we have done one clusters. So based on k-means algorithm we done, and the model training is also we done evaluation using this scikit-learn. So why it is more important in the data sense, because you are going to choose the right statistical or the machine learning model here. You are going to detect the outliers and the anomalies, and you're going to decide on the transformations, and you're going to apply the correct statistical test like normal distributions, whatever may be. This is what you're going to done by using this these analysis. Okay, fine. So next slide. Yes, so the applications, finally we were into the real-time applications of the world applications, which is fraud detection in banking. So fraud detection in banking, recommendation system, like you can use this in the Netflix, Amazon, all these things. There is a healthcare analytics are there. So you can also use in the self-driving cars and the AI. So these are some of the real world applications. In fraud detections means credit card fraud, money laundering, fake transactions. So all these things we can discuss with the fraud things. And coming to the recommendations, things like you're going to use with platform, Netflix, Amazon, Spotify, YouTube, all these things that you're going to discuss. And with handling the healthcare analytics, which is deal with patient records, the lab reports, insurance claims, and wearable device data, treatments, outcomes, everything that we were doing. And when coming to the point of this self-driving cars and all, right, like how this AI power self-driving cars are used. So detect the lanes, how we are going to read the traffic signs, avoid these obstacles, and making the decisions in the real time. So all these things are real world applications. Yes. So thank you so much. The session is concluded now with the real world applications. And over to the Ankita now.
Thank you so much, Ms. Amudha, for such an engaging and insightful session. I'm sure everyone here has picked up strategies and techniques they can apply immediately. If you guys are interested in learning more about various data science with Python, do check out our discounted batches of virtual instructor-led trainings on our website, springpeople.com. These VILT trainings are leveraged online from the comforts of your home and flexible as per your schedule and location. If you do not find any suitable batches, we'd be happy to discuss and schedule private batches for you. If you do not have time to join live online, then do try out our affordable self-paced courses. For more information, do write to us at training@springpeople.com or call our number displayed on the current slide. Now, Amudha, let's move on to the question and answer segment. If we got any, let's get them answered. Over to you, Miss Amudha.
Yes. So I got some of the questions, like if any references to learn, could you please provide the information? Yes. So yes, the one thing is like I already shared the link, which is okay. So the Scikit-learn is very important for this. So you can utilize the Scikit-learn. This is one of the important link. You can learn. Okay, I just passing this link in the chat box. Yes. Okay. So this is the references you can learn. And the next is, yes, it is possible to get the dataset to learn the machine learning models. Yes. So yes, you can do with the Jupyter notebooks. Yes, we can reference to learn. Yes, you can also get the references. And regarding the recordings, and I need to discuss with my team and the reference materials. Yes, we can have. Yes, Ankita, done with the questions.
Okay, and with that, we come to the end of today's session. Thank you once again for joining us. We truly appreciate your time and participation. We'll be sharing the recording of the webinar with all participants shortly. On behalf of Team Spring People, thank you once again. We hope to see you at our next expert webinar. Take care and see you soon. Bye for now.